I'm Miss Seaford, and I'm a third grade teacher at Bricky McLeod. And I'm excited to be working and reviewing with you today. And I'm really excited to be reviewing this unit with you that's going to be discussing fractions. This is one of my favorite skills that we work on in third grade. So today we're going to be taking a look at a math task over Unit 4, which will be looking at solving real-world problems using fractions. So first, let's take a look at our agenda and what we're going to be looking at and doing today. So first, we're going to be reviewing some key skills that's needed to complete our math task. We'll then take a look at analyzing a solution to a task that's already been solved. And then I'm going to give you guys a chance to take a look at that same task and see if you can try another approach to solve the same task that we just discussed. Then you guys will be given a task to complete on your own using some key skills that we've talked about today in similar ways. And then last, I'm going to leave you with a little game to help you practice those multiplication facts that we've been working on all year. So to get the day started, I want to kind of start with a number chat to wake up those brains and get you thinking about fractions. Now remember, all of this stuff should be review. But our brains may be a little rusty, so it'll be a good time to look back at some of those skills. So first, Ethan drew this picture here to the right, and he said that this shows that 1/4 is greater than 1/2. But Cole disagrees with Ethan. I want you to take a minute to think about who do you agree with. Do you agree that Ethan's correct, that 1/4 is greater than 1/2? Or do you agree with Cole that 1/2 is greater than 1/4? Now in my room we call this a tug of war. So we're going to have a tug of war. Do you think Cole's correct or do you think Ethan's correct? I'm going to give you a little bit of private think time to think about that. Now, some of you may agree with Ethan because when you look at this picture, it clearly shows that this shaded region on the right over here has a smaller area that is shaded than the region on the left. However, this picture doesn't help us to compare the fractions 1/4 and 1/2, and there's a big reason. And I think this is the reason that Cole disagrees. And it's because that when we're comparing two wholes, we have to remember that our wholes have to be the same size. And that's not the case for these two models. They have different areas and they have a different size. So I think what Cole was envisioning in his head is he was envisioning two wholes that were the same exact size, so they were covering the same area. And I think when we look at these two pictures, we would agree with Cole, and it's pretty clear to see that 1/2 is actually greater than 1/4. So in our tug of war, Cole would have been correct in saying that 1/2 is greater than 1/4. Now, thinking of that, I want you to think about, okay, well then how could we record those comparisons that Cole is telling us? How could we compare the fractions 1/4 and 1/2? I'm going to give you a second to think about that. Think about maybe some symbols that we could use or words that we could use to compare those two fractions. So just a quick review of how he'd say that. So Cole might have said that 1/4 is less than 1/2, just using those words less than, or we could have used the less than symbol, which we would say the same way. 1/4 is less than 1/2. Or he also could have told us that 1/2 is greater than 1/4, and we could have also wrote that out using our symbol to compare 1/2 and 1/4. So the big takeaway here and the big thing for us to remember is that when we're working with fractions, when we're comparing fractions, we're trying to find fractions that are equivalent, is that we're always using models that are the same size. Our wholes must be the same size. So we don't want to draw pictures where our wholes are different when we're comparing or looking for equivalent fractions. So the first skill that I want us to talk about, since we're talking about fractions, we need to make sure that we remember and understand what is a fraction. So remember that fractions are numbers that tell about equal parts of a whole. And when we think about that, there's two parts of our fraction. We have our denominator, which is the bottom number, and it always tells us how many equal parts are in our whole. We also have a numerator, which is the number on top, and this tells us how many equal parts that we have. So the numerator often tells us how many parts are shaded. It may be looking at how many pieces of pizza have pepperoni or how many pieces have been eaten. So I want to take a look at a picture model here. And if I was going to write a fraction for this, the first thing that I like to look at is my denominator. I want to look at how many equal parts are in my whole. And I see there's 1, 2, there are 3 equal parts. And that's something also very important to note. All of my parts are equal. They are the same size. So I know that I have 3 equal parts, and then I look and I see, okay, one part is shaded. So one part is shaded. There are 3 equal parts in my whole. So my fraction would be 1/3. Now we often use models, like the model here, the area model, to represent fractions, but we can also use a number line. Now I love this number line because it shows us a model as well as our number line, but it's just important. Number lines can be divided into those equal parts just like our models can. So you can see here we have 1 part, 2 parts, and 3 parts. So we have 3 equal parts, and then we can just label our fractions there. So I want to take a look a little bit deeper at how we can use those fractions on a number line. So just really quick to recap what we talked about on that previous slide, number lines can show more than just whole numbers. So we often think of number lines showing numbers like 1, 2, 3, and 4, but fractions can also be shown on those number lines. So for example, you can see this picture right here. The section between 0 and 1 on our number line shows 1 whole. And just like this picture model shows, we have 1 whole. And if you mark the sections to show equal parts, it is the same as dividing that whole into equal parts. So we've divided that area model into 4 equal parts. We've also divided our number line into 4 equal parts. Now, this is where it gets a little tricky sometimes with fractions on our number lines, is when number lines show fractions that are greater than 1. So to do this, we want to mark off each section between pairs of our whole numbers. So for instance, from 0 to 1 and from 1 to 2, we want to mark those numbers off into the same number of equal parts. So from 0 to 1, we've divided that into 4 equal parts. So from 1 to 2, we also need to count and divide into 4 equal parts. So next, let's take a look at equivalent fractions. Now, in our number chat, we talked about comparing fractions, which equivalent fractions is kind of similar. Equivalent fractions is looking for fractions that name the same amount of the whole. They cover the same area of our whole. So when we take a look at this picture, you're going to look at the circles, and you probably notice pretty quickly that the same amount is shaded in each of these circles. Each circle is divided into different numbers of equal parts. So the fractions that's used to name these shaded parts is different, but they are equivalent. And that's easy to see because we can clearly see that they are shading the same area, the same amount. Now, we can also see equivalent fractions using our number lines. So here we can see that 1/4 and 2/8 are located at the same point on our number line. So these two fractions are equivalent. Now, that's pretty easy for us to see. So remember, when looking for equivalent fractions, use models, use number lines to help you do that. So I'm going to let you try it on your own. I'm going to give you a minute to think. You can use the models or you can use the number line to help you identify some other equivalent fractions that you see. Alrighty, so some of you may have saw that 2/4 and 4/8 is equivalent because they're at the same point on our number line. You may have also said that 3/4 is equivalent or is equal to 6/8. And you may have even found another one and said that 8/8 is equal to 1 whole. Now the last skill that I want to talk about is comparing fractions. Now this is going to kind of be a recap from what we just talked about. But it's important when we're comparing those two fractions that we want to just figure out if there is more than or less than the other, or if they name the same amount, which we'll be talking about equivalent fractions. So we can look at fractions that have the same denominator. Remember, the denominator is the number that we find on the bottom. The denominator tells us how many equal parts are in our whole. So the first thing that I notice when I look at my two area models is first, they are the same size, which is so important. We don't want to make the same mistake that happened in our number chat. So we see that they are the same size, so we can compare these two fractions of 1/4 and 2/4. Now when our denominators are the same, you're really just looking at that numerator. Which number is greater? And 2/4 is greater, or 2, I'm sorry, is greater than 1. So 2/4 is greater than 1/4 because it's going to take 2 1/4, and we would only shade in 1 1/4. So 2/4 is greater than 1/4. A greater area is obviously shaded. We can also look at comparing those fractions on our number line. And the same thing, which one is covering more area? Which one is more? So we can see that 2/4 is greater than 1/4. Now we can also look at fractions that have the same numerator. When I think about this, I like to think, okay, if we're dividing a whole fraction, it's kind of like cutting up sheets of paper. So the more pieces that you cut, the smaller those pieces are going to be. Think about a pizza. The more pieces that you cut, the smaller the pieces are going to be. So when I look at these two fractions, I see that my numerators is the same. We have 4 parts shaded, but I notice that those denominators are different. I have one of my models is divided into 8 equal parts and 6 equal parts. So thinking back kind of to that cutting up paper, my 8 is going to be much smaller than my 6. So 4/6 would actually be greater than 4/8, just because the pieces, the parts in this first model are smaller than my 6. And then once again, we can look at it on a number line. This time I chose to draw 2 separate number lines. Up here I used one number line because my new denominators were the same. But we can clearly see 4/6 is greater than 4/8. And once again, it's because those pieces are bigger. So now we're ready for that first task. We're going to analyze the task, the 8-mile trail. So it says that Geo is running on the 8-mile trail at the Welcome Center, and he finds some trail plans. Now the trail plans say that he wants to plant trees along the trail every fraction of a mile. And he wants to use a fraction that is greater than 1/8 but less than 1/2. So we have unit fractions here. And remember, a unit fraction is a fraction that has a 1 in the numerator. So we want to come up with another unit fraction that's greater than 1/8 but less than 1/2. So that comparing is going to be really important for us here. Now Geo wants to find how many trees will be planted. It says to name a fraction that is greater than 1/8 but less than 1/2. We then are going to need to draw a number line from 0 to 8. Divide the sections between whole numbers to show your fraction, and then we're going to label each of those marks with a whole number or a fraction. And then last, we need to count all of the marks from 0 to 8 to figure out how many trees Geo is going to need to plant. So we're going to take a look at how he solved this problem, how Geo solved the problem. So first, he needed to find a fraction that was greater than 1/8 but less than 1/2. So when I think to myself, how can I do this? So when I think back to what we just talked about with key skills, I can draw a model to help me find a fraction that's greater than 1/8 but less than 1/2. And that's exactly what he did. He drew 8s and he drew his halves. And he knows that he needs a fraction that is greater than 1/8. And remember what we talked about. The more you divide up, the smaller your pieces are. So if we're going to want a piece greater than 1/8, we're going to want to try and divide it up into into a smaller number. And that's what he did. He divided it into thirds. And then he wants it to be less than 1/2. So it says that 1/3 parts are bigger than the 1/8 parts. The 1/3 parts are smaller than the 1/2 parts. Therefore, 1/3 is greater than 1/8 and 1/3 is less than 1/2. So he has completed that first part of the plan. So now he's ready to begin drawing his number line. So it tells us that he chose those thirds. So he's going to have to divide each section between whole numbers into 3 equal parts. Now, let's think, how many equal parts is Geo going to need? Well, remember, it's an 8-mile trail, so his number line is going to need to go from 0 to 8. And that's exactly what he did. So you'll see here's 0 to 8, and he divided it into 3 equal parts, into those thirds. From 1 to 2, he also divided it into 3 equal parts. And he did that until he got to 8. So once he had divided and labeled the marks on his number line, he was ready to begin counting the marks. So he counted from 0 to 8, and he started with 0. And when he counted those, he counted 25 marks. That means that Geo is going to need 25 trees to plant along the 8-mile trail. Now, I'm going to leave you and let you have some time to try another approach. So I think this should be the first page in your packet, page 202 and 203, and I want you to see if you can find another approach to the 8-mile trail problem. Now remember, as you're working, you want to remember to use the same size area models to compare your unit fractions. And you want to draw and label a number line with fractions. And remember, those fractions are going to need to be greater than 1/8 but less than 1/2. And once you've completed this task, I want you to think to yourself, are there only 2 solutions that work? Is there just your solution and Geo's solution? Or are there other ways that you could solve this problem as well? And last, you're going to get to try a task on your own completely. And this is a flower garden task. It's about Geo again, and he's helping to plant flowers near the 8-mile trail. Now, he wants to plant 2 flower gardens at the Welcome Center, and the gardens are circle-shaped. So I think it's important for us to note he wants 2 flower gardens. No more, no less. 2 flower gardens. Now, in the first flower garden, he wants to either divide the circle into halves, thirds, or fourths. Okay, and he wants to use a different color flower in each part. Now he just wants to use one color in each of those parts. Now, in his garden 2, he wants to divide the circle into equal parts again, and he wants to divide it into 6s or 8s. Now, you need to use the same color of flowers as you used in garden 1. The fraction of garden 2 that has each color flower should be equivalent to garden 1. So you're going to need to think back about equivalent fraction, that key skill we talked about. Remember, equivalent means that they cover the same amount. They cover the same area. So this task, you're just going to be looking for what 2 circles can Geo use to draw a diagram of the garden. You're going to need to choose a diagram from garden 1 and a diagram from garden 2 that are equivalent. So, and then last, I'm going to leave you with just something fun. We've been working on multiplication facts all year, so I'm going to leave you with a little game that you can play with someone around the house. And all you're going to need is a deck of cards, and the game's called Multiplication Duel. Now, if you've ever played like war with cards, it's very similar to that. So the first thing you're going to need to do is just remove all the face cards from a regular deck of playing cards. You'll shuffle those cards all up, and then you're going to pass them out to the players until all the cards have been dealt. You want to keep your cards face down, no cheating. And both players will turn over their top card and place it in the center of the pile at the same time. Now, the first person to correctly find the product, remember product is when we multiply 2 numbers together, will be able to keep those cards, okay? Now, if it happens that you both come up with the same product, correct product at the same time, it's time for a duel. And then both players will turn over 1 more card, and the person to find the product of those 2 cards first will win all of the cards. And you can play just through one deck, you can play until all of the cards have been played, and whoever has the most wins, or you can play until one person has all of the cards. So good luck with your tasks, and I hope you enjoy reviewing your math facts with this multiplication duel game. I've had fun hanging out with you guys and reviewing fractions. Good luck!